Alright, so here we go. We made it to the final section, 4.9, the why. It's fun to put all of our skills together. We've been working on all the different pieces, really going back to chapter 3. All of that's coming to a final conclusion here in our section. So in 4.9, all is fair game. 4.6, which was all the different solving methods, factor by grouping, sum of difference in cubes and squares, solving when b is equal to 0, factoring, quadratic formula, completing the square, any of that stuff, as well as synthetic division, which pairs up with the graphing on the calculator. Everything's coming together. So types of roots. The following statements are equivalent for any polynomial. So basically this is just reminding us all the different words that mean the same thing. 0 means the same thing as root, which means the same thing as intercept, and more specifically, an x-intercept. All right, so we call them intercepts, we call them zeros, call them roots, call them solutions. Oh, do they have that? Do I have that one listed here? Oh, here we go. Solution. And then also, it's helping us pull out factors, because all of these concepts are related back to so zeros, roots, solutions, x-intercepts tell us about factors. Do notice, though, because of the negative sign, that number is always going to be opposite of what you expect. Meaning, if one of our x-intercepts was 2, our factor would be x minus 2. Okay, so we're well past the 100th day of school. Finally, time to learn the fundamental theorem of algebra. Every polynomial equation with degree greater than 0 has at least one root in the set of complex numbers. I'll give you guys some strange news. The fundamental theorem of algebra, pretty lame. It's basically saying, hey, polynomials, so x that has any power 1 or greater is going to have at least one x-intercept. Could be imaginary, could be real. So nothing too fancy there. You think that with it being fundamental, in fact, wouldn't that be like 2 plus 2 is 4 or something like that? Nope. It's just saying that polynomials have solutions. All that's saying is that polynomials have solutions, whether you can see them or not. Then someone added in something called a corollary, which is an add-on. And this is the part that we'll actually use. So what this is saying is that a polynomial, we will know how many solutions to look for depending on what its highest exponent is. But they can repeat. And I've already been making mention of this. If we had an x to the 4th power, whatever else happens, there's going to be 4 solutions to that. All right. Now, what I didn't really tell you all yet is that can look like different things. There could be 4 different numbers. We could have x is equal to 1, x is equal to 3, x is equal to -2, x is equal to 7. There's 4. Another way to have 4 solutions would actually be this, where the solutions count twice. So if you have been wondering, why is I always making such a big deal out of us anytime we had the same factor twice, turning it into that factor squared? It's for this section. It's to help us understand that if you get the same factor twice, that solution counts twice. So another way to get 4 solutions would be, instead of having 4 separate ones, you could have the same solution. Say this one is like x is equal to 4. This is x equal to 1. But they're both showed up twice when you're doing synthetic division or something like that. Those count for 2. So essentially what's going on is the exponent. So 2 and 2 is 4. All of these single pieces are to the 1st power. So all of those add up to 4. It's basically saying the exponents associated with how many times your factors show up needs to add up to 4. So another solution path that could happen on this is you could have one thing show up twice, and then the other one show up 1 and 1. So there's a lot of variety that can happen on these. So be prepared for a lot. We saw that in 4.6. Variety of methods can come up here. Okay. So The directions that you'll see a lot of the times will say, solve each equation, state the number and types of roots. So that's talking about, real or imaginary. Basically, that's just saying, don't forget to include your imaginary. All right. So we got quadratic guy, x cubed guy, another x cubed guy. So none of these get particularly fancy. This is kind of just like a little warm-up here for us. So let's jump on in. If I see a situation like this, it's quadratic, I'm probably going to check factoring first. Could you use quadratic formula? Sure. But this is the easy type of factoring, so I'm going to check x and x. Can I find numbers that multiply to negative 21 that add to 4? I can. Positive 7, negative 3. So x is equal to negative 7. X is equal to 3. You could have actually just found this on this problem by graphing it. If you typed it into your calculator, you would see that it crossed over at negative 7 and 3. If you wanted to just do that and write down on like a quiz or test, hey, I typed this one in on the calculator, it's found across at negative 7 and 3, that's one of our methods. That'd be fine. The reason we need these by hand methods, though, is because, as you all remember, imaginary solutions do show up. Okay, number 2, it's x cubed. First step, though, I didn't mention on number 1 because there wasn't one, but check out GCFs. See if there's any GCFs in there. I see that I can divide both of these terms by a 2 and an x, which gives me x squared minus 25. Okay, so to solve this piece, I can go ahead and set it up equal to 0. If 2x is equal to 0, x is equal to 0. If I set up this piece equal to 0, I can use b is equal to 0 to help me use the square root method, where you get the x squared by itself, and then you square root both sides. So let's check and kind of see how this matches up so far with what we saw above. This was an x cubed situation, and we had 1, 2, 3 solutions. I knew there was going to be 2 solutions coming out of this factored piece because exponent was 2. And then that plus or minus made that happen. This one, it was x squared. I was looking for 2 solutions. There they are. 1, 2. All right. This guy here. Checking out GCFs, greatest common factors. Biggest thing I can divide these guys by is a 4 and an x. Gives me 3x squared plus 25 is equal to 0. Can solve that piece easily. 4x is equal to 0, divide both sides by 4, x is equal to 0. This piece is going to give me 2 solutions. You can see that because it's squared. It's another situation where I'm able to use b is equal to 0. So I'll subtract 25 from both sides. I'll divide both sides by 3. And I'll square root and square root. X is equal to plus or minus. There's a negative under the square root. This negative becomes an I. I'm not going to throw up a big fuss about this. You could actually, if you left it at square root of 25 over 3, I'd be fine with that. If you left it like that, because we're going to cover in the next chapter how to take that further. If you also square rooted the 25 up top, left the 1/3 in there, like that, that'd be fine too. Don't forget though, we need that I. So really, I kind of did a bad thing on this. Don't put your I second. Bad job, Mr. Coddle. X is equal to plus or minus I square root of 25 over 3. Because the things that we take the square root go out front. Put that I out front. You're not wrong if you put it under there. So this is actually right. I put big X's over it just because it's not the way I want you to write it. It's not actually wrong. It is wrong if I do this, though. If I extend that square root line over the I, now it's definitely wrong. Because the square root needs to be on the outside. So that's why you'll put it out front, so that you don't lose it, or you don't accidentally put it back in. Set it out there. Okay, so those are all just kind of warm-ups. allowing us to see, what's going on here. I was expecting 3 solutions. I had 1, 2, and 3 because of that plus or minus. They can be real, they can be imaginary, anything goes. So let's use the last 5 minutes here to check this out. Alright, and so it's just having us realize that some solutions have to come in pairs. And it's saying, hey, it's complex conjugate theorem. If A and B are real numbers and B is equal to 0, B is not equal to 0. Saying that when we're getting imaginary solutions, plus or minus is going to come into effect. Because anytime I'm square rooting a negative number, I'm going to get plus or minus something. So square root solutions split into 2. So means what other type of solutions will come in pairs? Square roots of other numbers as well. So square roots will also lend itself to plus or minus. So what that means is that find the other solutions based upon the given solutions. They said, hey, our solutions are negative 3, cool, 2i, and 5 plus I. That it auto-capitalized that for me. I want it to be lowercase I. So what this means is if somebody told us that, you'd say, okay, cool, solution's negative 3. It's impossible to only get 2i. 2i would have to also come with negative 2i. i's always come in pairs. So 5 plus I would also have to come with 5 minus I. So that's all this is having you understand. If I told you that those were the roots, you'd say that, oh, well, I guess x is really then negative 3, x was plus or minus 2i, and x is also 5 plus or minus I. And the quadratic formula is one of the guys who gives us imaginary solutions, right? And you'll notice in quadratic formula, there's a big plus minus. It's impossible to escape it. When we use the square root method up above, they both had plus or minuses in it. Can't escape it. Square root solutions and imaginary solutions always come as pairs. Now, a regular solution, they don't just duplicate. I wouldn't go and say, oh, well, negative 3 also has to have a positive 3. Not unless they told us it came from a square root. If they didn't tell us it came from a square root, then we are safe to assume it's just a regular old solution and does not need to have its plus or minus pair identified. So on this one, if they told us that our solutions were negative 5, say cool. Square root of 7 means it also had to come with plus or minus. Same thing for this one. So basically, this is just a whole section on, as we're going through these very difficult problems where all this stuff come together, don't forget about your plus minus. If you forget about your plus minus, you'll be looking for solutions and can't find them, and you'll get all frustrated because you'll know that, if your polynomial is x to the 5th power and then a bunch of stuff, you need to be looking for 5 solutions. You'll be like, oh, I just can't find some of them. If you forget your plus or minus, you'll be looking for stuff that you already found. You just forgot to put the plus or minus. So always be on the lookout. If you're taking a square root in an equation context, it's going to yield a plus or minus. In the second part of this video that we'll check out the next day, we're going to just solve our way through some of these. This is tied up with the 4.8/4.9 homework. You technically are equipped to do all this. You might not feel equipped. If that's the case, you can wait till the next part of the video. But you do have all the skills you need to do it. So you would be free to, jump onto that homework with your remaining time here if you wanted to. Or if not, you could check back. Let me list out some of the videos, that might be helpful for this section. In our class videos, you could check out the calculator videos, because those skills will come in handy. You You could check out any video about factoring, because that'll help. And you can check out the b is equal to 0 video. So all those guys would be helpful as we're going to start to take down the big problems, everything coming together on the next day's video.